to a video on equivalent fractions. First of all, we're going to start with a simple one. Start off with 1 over 2. And I'm using these circles up top, or close to circles, as sort of a visual representation. I like to think of fractions in terms of pizza or cake or pie. And let's say that this is a pizza and I'm hungry and I ate an entire half of the pizza. So here we go. I ate half of the pizza and that was plenty. Now I might go somewhere else and somebody else would say, wow, I had 4 slices of pizza, or 2 or 8 or whatever. And you might think, oh wow, how is it possible they could fit that much in them? Well, they didn't talk about how many slices the entire pizza was made of. Perhaps it was split into 2 like mine, and they had a lot. However, let's say, hypothetically speaking, they ate the same amount as me. But instead of the pizza being cut into 2 equal slices, and the 2 is represented by the denominator is how many slices altogether one of the pizzas was cut into. The top number, the numerator, represents the amount that we're actually talking about, the amount that I ate. Okay, so let's say this time somebody else had pizza, and they had a pizza that was cut into 4 equal slices, but they had 1, 2 out of possible 1, 2, 3, 4 slices, and they ate the same amount that I ate. And then someone else came along and said, well, I had 4 slices of pizza. And before we call them a glutton, we might ask them, how many slices was that pizza cut into? And that's not even talking about how big the pizza was in the first place. Is it a 16-inch or a 12-inch or a 10-inch? But let's say this person also ate this much. 1, 2, 3, 4 pieces out of a possible 1, 2, 3, 4, 5, 6, 7, 8. 4 out of 8. And by looking at these 3 examples, you can see that this person ate the same amount as this person, who ate the same amount as this person. And it's easy to see that when we're talking about the circles themselves. And we can add an equal sign in here because we know that this is the same as this is the same as this. Now, these are equivalent fractions. There's another way to do this too. Let's say I have a fraction of, say, 2 over 5. What that tells me is the total of the circle was cut into 5 equal slices, and we're talking about 2 of them. And I want to figure out an equivalent fraction. But let's say I don't want to take the time to draw a circle or whatever. And I'm trying to figure out, well, how much or what would the equivalent be if I'm talking about a fraction out of 20? So if it's 2/5, what is the equivalent fraction out of 20? Well, I need to figure out what did I do to 5 to get 20. In this case, going back to our original fraction, I had 1 over 2, and it became 2 out of 4. What I did was I cut each side in half. Okay? I multiplied. In this case, 5 times 4 equals 20. So I'm taking my 5-sided, 5 equal side pizza, 1, 2, 3, 4, 5, and I was talking about 2 here, and I took each of these slices and I cut it into an additional 4 slices. So you'll see I'm cutting each slice in half and then in half again. I could count these up to make it 20, all right? So at the same time, I look at my squiggle, which was here, and I could count up these slices too. But these, which were 2 slices, what I need to do is I also multiplied those by 4. 2 times 4 is 8. So an equivalent fraction of 2 over 5 is 8 over 20. I can do the same thing going the other direction. Let's say I've got a fraction of, say, 10 over 15. And I want to see what an equivalent fraction would be out of, say, 3. What do I do to 15 to get 3? I divide it by 5. 15 divided by 5 equals 3. So again, if I had 15 slices, I would take 5 of those slices and merge them into 1. 5 of those slices and merge them into 1. Whatever I do to the bottom, I also have to do to the top. 10 divided by 5 equals 2. Therefore, an equivalent fraction to 10 over 15 is 2 over 3. Some might say, well, why don't I add? Why don't I take 1 over 2? I know that 2 plus 2 equals 4. Whatever I do to the bottom, I have to do to the top. 1 plus 2 equals 3. But over here, I have 1 over 2. Over here, I have 2 over 4. And if this were true, then this would also be shaded in. But that is not the case. Therefore, I know I have to multiply or divide in order to make equivalent fractions. I hope this has been helpful. If you have questions, please leave them below.